What is going on, guys? Welcome back to another Swift video. In today's video, we're going to be taking a closer look at extensions in Swift. So we're going to look at a few examples in a playground, some cool things we can do with extensions, and then we're going to jump into a project to take a look at a little bit more of a practical example and how I would use the things that we're going to learn. So that said, make sure you absolutely destroy that like button down below for the YouTube algorithm. Get excited. If you're new to the channel, hit subscribe while you're at it. Let's jump right in with the playground. So I'll create a playground here. We can stick with the blank one, leave the name as the default. Let me go ahead and expand this Xcode window to give ourselves a little more room to work. And hopefully that font size isn't too small for you guys. Let me bump it a little bit. And let's get into extensions. So hopefully you're familiar with a basic extension. If you're not, you can go take a look at the intro to Swift playlist I have where we will talk about them at a basic intro level. But basically, this is what an extension is. You can have a class or a type, and you can extend it with computed properties or functions. So let's take a look at the first thing that I wanted to cover. So let's say you're given an array, and this array holds various strings. And in our case, we're going to put names in here. So we're going to say Joe, Abe, Zoe, Carl, Sam, Dom, and sure, let me put myself in here. Why not? Okay, cool. So given this array of strings, in this case, they are names. Let's say in our app, we have a need to always alphabetize strings in an array. So the simple way we can achieve this is by using the sorted by function. We can say sorted by, and we can basically return $0 less than $1, which is the first and the second element. And we can say this is sorted, and we can go ahead and print this out. And if we open up the console here and I hit run, we'll see our array is sorted alphabetically. But doing this over and over is a little verbose, and this isn't really readable in terms of what we're doing. Now, us as developers, we know what it is, but imagine someone comes in from a different language. Wouldn't it be cooler if we can say something along the lines of alphabetize? I think that would be a lot cleaner to read, and it also looks like a much more reusable function across our code base. So how do we achieve this? Well, surprise, we can use extensions to achieve it. So we're going to write an extension on the array type, and we're going to constrain it with a where clause. And we're going to say where the element is a string, we're going to basically add more functionality. And what we're going to do is we are going to create a function called alphabetize. Alphabetize. This will return an array of strings. And what we're going to do is we're going to return, return self, and we can paste in sorted by. So now, let's see if I spelled this right. Alphabetize. Definitely spelled that wrong. Alphabetize. So now if we go ahead and stop this execution here, and I clear that out with the command K and run it again, you'll see we get the exact same result. The difference of this approach is, A, this is more readable, and it's more reusable, right? Like you don't need to write this sorted by thing every single place you want to basically do this type of sort. Now, granted, this is a pretty simple example, but let's say you had a much more complex example where you wanted to order certain objects, right? So let's say like you wanted to write an algorithm to order some type of object in a particular kind of sorting fashion, or the various algorithms that are out there if you wanted to order things ascending or descending. The point of this type of approach with extensions is it's really powerful for writing reusable code with these types of constraints. So let's say I was given another array. Let's call this array 2. And let's say it had integers in it, right? So this is now a array of integers, and I tried to call array2.alphabetize. You see it doesn't pop up. And the reason it doesn't pop up is because we've constrained this extension where element, which is a Swift keyword, which is each element in the array, is a string. Now, consequently, what you can also do, because array is a wrapper on top of another sub-implementation called sequence, you could just extend sequence and say where the sequence is a sequence of elements where the element is string. It essentially is the same thing under the hood. Array is just implemented as a wrapper on top of sequence. So that is the first thing that I wanted to go over as an example here. And the second thing is fairly trivial as well, but it's very popular in terms of a pattern in large code bases. I find myself doing it a lot more now. And it's something that if you get into the habit of doing early on, it'll probably benefit you as your classes get bigger and the more code you write. And that is using extensions to segment out various parts of a class, right? Whether it's some type of functionality or whether it's a conformance to a delegate, right? Or a protocol, rather, I should say. So let's say we have a class called view controller, and it inherits from UI view controller. And let's say this class is a, I don't know, let's call it home view controller. Let's call it feed view controller. And it shows like a Facebook feed or something, right? So in here, you would have functionality like view did load, all the view functionality like view did appear, and you would have like view did disappear, et cetera, et cetera. And let's say you also had some networking logic in here like fetch feed, and you have things like get more info about post, and you get the point kind of. So like you have some functionality in here about the view lifecycle, and you have some functionality in here about your feed and like fetching it and stuff. You can quickly see how this will become very large in terms of how much code you have in here, how many things it's doing pretty fast, right? So before I actually introduce the extension to this, let's do one more thing. Let's say this class also has a table view in it, and it can conform to the UI table view delegate. Let's say we also have a search bar in here, and we're going to conform to the UI search bar. I think there's a UI search bar delegate. UI search bar delegate. Let's say we conform to both of these as well. And let's say we want to bring in functionality for both of those. So for the search bar, we'll bring in search button clicked. And for the table view, we'll bring in did select row at index path. So again, to stay with the prior theme, like our class is starting to get big. So where the heck do extensions come in? So let's say we wanted to separate out all of our functionality about the table view. Well, that's pretty easy. Let's write an extension on this feed view controller, and let's bring in that table view function. And instead of putting it in the primary implementation, let's put it in here, right? So one thing that you also need to do is instead of conforming to the class here, the UI table view delegate, you can actually extend the conformance of the protocol on the extension itself. So you can do things like this. So I'm sure if you've been following this channel, you've seen me do this a number of times in my videos. It's such a habit at this point, and there's a lot of benefits to it in terms of just code organization. Are there any functional benefits? There are in some cases, but for the most part, not really. It's more of a stylistic thing, I would say, but I also think it's more of a bit of a seniority thing, right? As you get into large projects and you really want code to be maintainable, it's really important that you organize things in a way where things can scale. Otherwise, you're gonna be left with a big mess. So let's also do the same thing for this search bar guy. We can add another extension on this, throw that there, move the search in. Oops, let me get that F also. And people will also like to, what they like to do is, me included, I like to add marks on here, and you can actually separate out in the Xcode IDE, you can jump to various parts of a file based on these marks. So it really helps kind of paint the picture of like, okay, everything in this extension is related to the UI search bar delegate. And similarly, you don't have to always conform to a protocol. What you can do is you can write an extension for your own stuff. So let's say we just want to write an extension on feed controller, and this one is going to be related to fetching and networking. We can do that. That's totally cool too. And we can just keep this primary class declaration here. We can just say this stuff is just the view lifecycle. So it's a really good way to separate things out. I'm a big fan. I encourage you to follow the pattern. I used to not like this pattern, But I realized once I started working on a controller with like 20,000 lines, which in itself is a big issue because you should not have a controller with 20,000 lines at that point. Your class is doing way too much. But point being, like once you get into big files, it becomes really messy and hard to find things. And oftentimes what people will also do is you can split up these files and things into various, or these extensions and things into various files. So it doesn't have to be in the same file. So cool. That all said, let's jump into a project and let's take a look at how this would be implemented, this pattern kind of in a real world scenario, pretty similar to what we just did. I'm going to call it my table view and we'll get started with this implementation. I'll do two practical examples of both of the things that we just went over, extensions with where clauses, as well as extensions with protocol conformances and splitting up code. So what we're going to do is we are going to build a quick table view here and separate out the code. I'm going to stick with a, sure, why not? Let's stick with the SE. So first things first, we want to create a table view. So I'm going to do this fairly quickly. If you're not familiar with table views, take a look at my other videos on the topic. I have way more than I care to admit at this point. Big fan of table views. You can do a lot of cool things with table views. So let's create a basic table view here. We're going to add it. We're going to set up its delegate and its data source. Now we're going to use extensions to conform to said protocols. So we're going to extend the current class we're in, which is view controller. We're going to bring in the table view delegate, and we're going to bring in the table view data source. Whoops, let's put that colon there. And let's see, now we actually want functionality in here. So this one is the delegate. So we're going to say did select, and we'll just print out for now selected. And in this one, we need number of rows. We'll return data.count. We haven't created data yet. We'll do that in a second. And we're going to say cell for row at index path, and we're going to dequeue a cell real fast, like so. We're going to use cell as the ID, pass in the index path, and we're going to set up the text label with the nth element in our data array, which we will create in a moment, and then we'll return that cell. Let's not forget to go and register a cell on this table. So let me register a base UI table view cell. Make sure the identifier is cell since that's what we use down below. Let's create that data array on here. So this will be a private array. It'll be called data. Let's just use strings for now. And I'm going to set this up real fast here. We'll just append in a few things. We'll just say Joe. And let's not forget to give ourselves a frame in did layout subviews. And let's make this table the entirety of the screen. So cool, that's a basic table view setup. Let's go ahead and just run it and make sure it works. And then we'll add another extension and we'll create a more interesting object for data. So let's see, where's that simulator? All right, so what the heck, where is our table? There it is. Okay, so the simulator loves to be slow. Bear with it, but here is our table view, pretty simple. Cool, so now let's create a more interesting object that we can put into this data array. So I'm gonna create a struct. I'll put it right up here in this file so we don't have to switch between files. And let's say we want to, let me think, what's an interesting thing to sort out? You guys could probably tell that I wing half of these videos and don't really plan out examples, but I think it's more fun that way. So let's say we have a struct of restaurant, let me spell that correctly. And this is going to have a title. And we'll just keep a title and a rating for now. And the rating will be an integer. And basically what we want to do is we're going to want to show a table of these restaurants but we want them to be ordered by the highest rated ones to the lowest rated ones. So let me go ahead and change this to an array of restaurants. And we can drop all of these because they're not strings anymore. And for the cell for row, we don't want to assign it to the restaurant itself. We want to assign it to the title. And I'm also going to want a custom subclass of the cell so we can have a subtitle label. So we're going to say subtitle cell is a UI table view cell. And in here, we're just going to override the initializer. And we're going to say super init with style. We want the same one. Come on. We want, why is it being difficult? Let's see, super override. Just do it manually. We'll say the style is, okay, something is weird. What did I mess up? Restaurant, restaurant, restaurants. Let me get rid of this real fast. So say Command B, make sure it's still working. Okay, it's still working. Let's add a custom cell. It'll be a subclass of a UI table view cell. We're going to bring in the initializer with the style, call super init with the style, and we're going to want a subtitle style, pass in the reuse identifier. We also want the init with coder. It's going to yell at me in 2 seconds that we need it. There it is. Hit the error, hit fix. It'll stub it out for you. And let's go ahead and register this kind of cell. And what we're going to say in here now in the cell for row, we can use the detail label, which is a subtitle label. And for this, we're going to say the rating is data, index path, row, and we're just going to pull out the, what did I call it, rating. So let's make some restaurants and throw them in here. So this is complaining because this is an integer and we're trying to append it to a string. So let's use string interpolation and throw it on in there. Let's add some restaurant objects in here, and then we'll take a look at adding a extension to sort all of it. So I'm just going to assign it here. So we're going to create a restaurant. We'll say burger joint, and we'll give it a rating of, I don't know, let's say it's a really good burger joint, 100. And let's copy and paste these. And let me do Control I to fix that indentation. Wow, it screwed up the indentation quite a bit. It's because I didn't put commas in front of anything. So let's Command Z all of that. Sorry, bear with me. Let me expand my window to a little bit so you guys can see more of it since I upped the font size. But let's copy that comma while we're at it. And let's paste these in. Fix that indentation. Let's change up the ratings and the names. So this one, we're going to say seafood. We'll say, I don't know, let's put Chick-fil-A in here just because I'm getting Chick-fil-A later. Let's put in, I don't know, man, I shouldn't have gone with restaurants. Now you guys are going to judge me on how many restaurants I know. Let's go with Burger King. Let's go with Thai food. Let's go with Indian food. Let's go with American Grill. And we'll go with random diner. Let's change up these and make these totally random. Apparently the Indian food place sucks. Make this 79. Burger King's not that great. We'll make it a 5. Chick-fil-A is definitely the best out of all of these. And seafood's not absolutely terrible. Let's give this like a 50. So let's go ahead and hit Command R. Let's make sure we get our things listed out here with the ratings. So we definitely see we get everything listed out, the title and the subtitle, but we want the restaurants with the highest ratings to be at the top. So what I'm going to say, before we actually update our table view, or rather before we set up the table view, we want to add an extension to this restaurant element in an array. So we're going to extend array where the element is a restaurant. And in here, we're going to add a function and we're going to say sorted by highest, rather let's do this, sorted by rating. And we're going to say highest first. This will take a Boolean And we're going to return a sorted instance of the array with restaurants. And this is complaining because we need a return. Let's just put an empty return for now. So the first thing we want to do in here is we're going to say guard self is empty, right? So if this isn't empty, we can continue. Otherwise, just go ahead and return an array, right? An empty array, it's already empty. No need to do an algorithm over it and sort it. Now what we want to do, as soon as we get rid of my antivirus pop-up, which loves to make an appearance in these videos, we want to create a sorted array. We're going to say self, and we're going to say sorted by, and we're going to return $0.rating. Let's see, $0. Let's actually put first and second in here because it's deciding to be dumb. We'll say first, which is a restaurant, dot rating is higher or greater than second dot rating. And I believe that's what we want. And we also have this inbound highest first. So what we're going to say is if it's highest first, do that. Otherwise, let's see if I can get away with this really fancy ternary operator. Otherwise, do it less than, right? And then we're going to return. We can actually just put the return statement here. We can return it right there. So here is an extension where we have added this function, which takes in a parameter, and this will allow us to sort any collection of restaurant objects based on the rating. And we additionally added this Boolean where we can say, do we want the highest first or lowest first, right? So now what we can say here, once we have this data array, here we can say data equals data and sorted by rating, and we want the highest to be first. So let's go ahead and hit Command R. Let me see if I screwed it up. Okay, so it definitely works. Chick-fil-A is definitely the best. I know I spelled that wrong for whoever's going to put it in the comments. And, you know, they're sorted highest first. Let's take a look at making this false and hitting run one more time. And you'll see now there'll be an inverse order where we have the highest rated at the bottom. So also, no offense to Indian food, love Indian food. This is just an example's sake. So that is a way where you can practically use these types of extension patterns in real world applications. The protocol separation one is pretty trivial. I think this one up here where you add extensions on classes where you have clauses can become pretty powerful. Now this struct that we have added is a pretty simple object in itself, but based on it, we can sort things and we can also put in parameters and such. So you can imagine how complex this can get and how great of a utility this can become once you start dealing with objects with dozens of properties. So this video has definitely gotten longer than I anticipated. Hopefully those two examples were pretty clear. Thanks for watching. If you haven't smashed that like button already, make sure to do so for that YouTube algorithm. I'll be uploading the code for this to GitHub. I'll be sharing it with the coder level members. If you're not familiar with that, check out my last video about YouTube memberships. Leave a comment down below if you have any questions, errors, you want to say hi, you have a suggestion for a video, whatever it may be. Thanks again for watching. I will see you in the next one.